Day 254 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 77, combinations. The difficulty level is medium, but don't you worry because we're going to keep the solution as simple and easy to understand for everybody, no matter what level of your programming journey you may be on. So let's get into it. Question 6. Given two integers n and k, return all possible combinations of k numbers chosen from the range 1 to n. You may return the answer in any order. So let's look at example 1 so we can break that down. It's pretty self-explanatory, though. I think y'all will be able to understand it. In example 1, we have the input n equals 4 and k equals 4. The output, what that means is we have to find every combination of numbers 1 through 4 with two numbers or two integers at a time, right? Combinations of two. So we need to find every combination of two numbers between 1 and 4, right? Not that difficult. So the output is a 2D array. First array is 1 and 2. Second array is 1 and 3. Third array is 1 and 4. Then next array is 2 and 3. Then the next array is 2 and 4. Final array is 3 and 4, right? Explanation says there are four choose 2 equals 6 total combinations. Note that combinations are unordered, i.e. 1, 2, and 2, 1 are considered to be the same combination. So like I said, it's pretty self-explanatory, y'all. We just want to find every combination of numbers that we can create between 1 and 4, right? So if we have 1, 2, 3, and 4, we want to find every combination that we can find. So 1 and 2 would be 1. Boom, we could do 1, 2. Then it'd be 1, 3. Then it'd be 1, 4, right? Boom. Now, we already did 1 and 2, so we could skip 2 and 1 because it says right here 1 and 2 and 2 or 1 are considered to be the same combination. So we could skip 2 and 1 and we could go straight to 2 and 3. Boom, 2 and 3. Then, excuse me, this is all in the same 2 and 3. Then we could go 2 and 4, right? And then we got to do the threes, right? So we already did 1 and 3. We already did 2 and 3. So only thing left to do is 3 and 4. Now these should line up with these. So let's see 1 and 2, 1 and 3, 1 and 4, 2 and 3, 2 and 4, and 3 and 4. So these are all the possible combinations that we can make out of these numbers right here when we're only doing two numbers at a time, right? Because k equals 2, that's how we know it's two numbers at a time, and these are all the possible combinations. We have to return all of the possible combinations. So we're not just returning the count this time, we have to actually return all of these combinations, right? We're going to use backtracking in order to do that, but let's look at example 2 before we get into the solution, right? So in example 2, it's a little bit more simple, a little less explanatory. This time n equals 1, k equals 1. So the only combination that we can make of one number, and the one number is 1, is 1. Therefore, there is 1, choose 1 equals 1 total combination. So that's what they want us to do, y'all. That's what they're asking. But before we get into the solution, y'all, if you need any new Apple AirPods, go ahead and check out that link in the description. And then after you do that, don't forget to like, comment, and subscribe, y'all. Now, let's get into it. So the first thing we are going to do, right, we need to figure out how we're going to solve this problem, and we are going to use some backtracking in order to do that, right? So the first thing we need to do is we need to create an array which will store all of the valid combinations, right? Because remember, this is an array, but it's a 2D array, so it has arrays inside of a bigger array, right? So we need to create our 2D array that will store all the combinations. So in order to do that, we are just going to say var res. So we're going to declare a variable, we're going to call it res. We're going to set that equal to a 2D array of integers, which represents this right here. And we could just initialize it with a blank array just like that, right? Boom. Now we're going to use a little bit of recursion to perform our backtracking. So in order to do that, we're going to create a func inside the main func, right? So we're going to create another function. We call that func. We could call that backtrack. Boom, open up the parentheses. It's going to have a path, so underscore path, and path is going to be path is going to be an array of integers. And we're going to say comma, underscore max, and max is just going to be an integer just like so. I'm going to open up the brackets. Now let's get into it. First thing we need to do is create a base case. If the current path length equals k, it's a valid combination, right? So in order to do that, we could just say if path dot count equals k, because remember, we only want k amount of numbers at a time, so we need to make sure that the count is equal to k. So we're going to say if path dot count equal sign k, we're going to open up the brackets, and we are going to say res dot append, open up the parentheses, path. We could just add the combination to the result array, and then we are going to come down here and we're just going to say continue, just like that. Or excuse me, not continue, y'all. Sorry, return. Sorry, y'all. We're just going to say return. Boom. Now we need to create a mutable copy of the current path. So in order to do that, it's pretty easy. We could just say var path equals path. And now we have a mutable copy of the path. Now we need to see if max plus 1 exceeds n, then no more numbers can be added and we need to exit the function, right? So we're just going to say if max plus 1 is greater than n, n, what we're going to do, we could just say, we open up the brackets and we'll say return, just like that. Now we need to iterate through the numbers from max plus 1 to n. So in order to do that, we're going to say, come down here, we're going to say for I in max plus 1 up to not less than n, open up the brackets. And we need to see if the remaining numbers are insufficient to complete the combination, then we need to just skip it, right? So we need to say if n minus I is less than k minus path dot count minus 1, we could just say continue, which will skip it for us. Boom. Now we need to add the current number to the path. So in order to do that, we're just going to say, we're just going to say path dot append, open up the parentheses, I. Now it's time to recursively call the backtracking function with the updated path and the current number. So in order to do that, we're just going to call the backtracking by saying backtrack, which is the name of the function, open up the parentheses, we're going to pass in the path, and I is the parameters. Now it's time to remove the last element to explore other possibilities. So in order to do that, we could just say path dot remove, open up the parentheses, at colon path dot count minus 1. Now it's time to start the backtracking process with an empty path and initial max value of 0. So for that, we're just going to come outside of the for loop. Or actually, we are going to come outside of the backtracking function altogether. And we're going to just say backtrack, open up the parentheses, square bracket, comma, 0. Now we can return all of the valid combinations. And in order to do that, we're just going to come down here and say return res, just like that. Now that should be all she wrote, y'all. Should be all she wrote. Let's run it, see how it runs. Let's see what we got. Y'all. Let's see, and it's accepted, y'all. So let's submit it. Make sure it stays accepted after we submit it. Let's see. That 31 milliseconds beats 50.79% of users with Swift, y'all. Not too bad, not too bad at all. We'll get those numbers up as we continue down our LeetCode journey. Right now, we just want to be able to solve the problem that is presented to us, and we're going to need a simple and easy solution to do that so that we can learn from it, and we'll be able to apply that knowledge that we learned further down our LeetCode journey when we do questions, new questions that we may have never seen before. We'll still have the knowledge and we will have internalized what we've learned before instead of doing a solution that we don't understand and then we don't learn anything and there's nothing to apply later. So that's all for today. I hope y'all learned something. Get one more look at the code before we leave. One more look at the code. I hope y'all learned something today, y'all, and I hope to see y'all tomorrow for another day, another LeetCode problem. See y'all then.